Okay, here we have the 11.3 Part 2 homework. I'm just going to work through it. Ideally, you do this on your own, and then you watch this video if you need help. Alright, so here we have a rectangle minus a circle, and the circle has a radius of 4. So that would be base times height for the rectangle minus pi r squared for the circle. So that's an 8 by 14 minus 4 squared, and I believe you get 61.7 feet squared for that one. Alright, next one, same idea, it's just a square minus a circle. So that's 18 times 18, and then the radius of that would be 9. Alright, if you work that out in your calculator, I believe it's 69.5. If I'm going too fast, feel free to pause and rewind. Alright, same idea here. We've got a large circle, and then we're going to cut out the inner circle. So that would be pi r squared for the large circle minus pi r squared for the small circle. It's a little confusing, but the whole radius of the large circle is 5 plus 8, which is 13. And the radius of the small circle is 5. So therefore, we've got 169 pi here, we've got 25 pi here. Because these are like terms, you could just write the answer as 144 pi, which is approximately 452.4 centimeters squared. So either one of those answers is good. Alright, now it starts getting a little bit more complicated, a little bit more technical. We're going to start with the trapezoid, which is the average of the bases times the height. Then we're going to take away a triangle, which is 1/2 base times height. It's a trapezoid minus a triangle. Alright, so the top base is 18, bottom base is 12, and the height, if this is a mid-segment, that means it's in the middle. So that means 7 here and 7 here, so that makes the height 14. And the base of this is the mid-segment, and the mid-segment is the average of these two bases. So what do you get when you average out 18 and 12? You get 15. So this base is 15, and the height is 7. Alright, so you can plug that all into your calculator just like that. You get 210 for the trapezoid, you get 52.5 for the triangle, so it's 210 minus 52.5, which is 157.5. And that'll be our answer. Alright, and now getting even more technical. This brings in 11.3 Part 1. We have to take the triangle and subtract the circle. Now, the key to this is that the triangle is equilateral, which makes it a regular triangle, which makes we can use 1/2 apothem times perimeter. Alright, therefore, we gotta work this out a little bit. Let's look at this triangle. And what we need to do is we need to find the apothem. And we can do that using this right triangle. This was 11.3 Part 1. So if we look at this triangle, I'm gonna bring this triangle out here. It's this triangle right here. There's my apothem. And it turns out that in a equilateral triangle, this angle is 120 degrees. That's 360 divided by 3. And so this is 120, which makes this a 60 degree angle. So therefore this is a 30, 60, 90. And if this whole length was 10, that makes this 5 apiece, 5 and 5. So therefore, if we have our 30, 60, 90 figured out, A is 5 divided by root 3. So A is 5 divided by root 3. Alright, so now we can work on doing our stuff. This is a triangle minus a circle. So for the triangle, because it's regular, equilateral, we can do 1/2 apotheta times perimeter. For the circle, we can do pi r squared. So for this, we can do 1/2, and it's okay to keep the root in the denominator because we are going to, we're just going to approximate, so it's no big deal. The perimeter of the triangle is 30. The radius of the circle is the same as the apotheta, so that's another 5 divided by root 3, and then we got a square. Alright, so we can plug this all into our calculator. I'll go ahead and show that as well. So I'm going to do 0.5 times 5 divided by root 3 times 30. So you got 43 for that one. And then for the circle, that's pi times 5 divided by root 3 squared. Nope, not that one. Squared. Oh boy. Okay, I just made that complicated, didn't I? Squared. There. 26.2. And now when I do that minus that, I get about 17.1. And it is no units, so we'll just do units squared. And we got a little bit more complicated. Alright, for this one we've got, we need to find the area of the shaded region basically, so we're just going to do a triangle plus a rectangle. Alright, so this triangle is 1/2, the base is 25, and the height is 26 minus 15, so 11. And this rectangle here is 25 by 15. Alright, so therefore we've got 512 when you add that together. 0.5. Alright, so that's the whole shaded part. Now we got to start subtracting. So we got 512 for the whole part. And then it tells us in the directions, it says the door is 7 by 3, so that's an area of 21. We got to subtract the door. The large window is 5 by 3, which is 15. Subtract the window. And then each small window is 2 by 3, so that's 6 for each of those. And that should be our final area that we'd have to paint. And then we take this number to the paint store and figure out how many gallons of paint we need to buy. Alright, that's the front side. Now on to the back side. These are irregular polygons, means you gotta cut them up a little bit. In this scenario, we can just see that we've got a rectangle plus 2 half circles, and 2 halves make a whole, so I'm just going to do base times height plus pi r squared. So that's 7 times 6, and the radius, if that length is 6, then the radius would be 3. Alright. So if you plug that into your calculator, you get about 70.3. And we're going to use feet squared. For 8, obviously a weird shape, so we're going to cut it. I'm going to cut it there. This is a 5 by 5, obviously diagrammed out to scale. So that's 25 units for that one, millimeters squared. And then this ends up being 20 now, if this is 5. And then 20 times 15 is 300. For a final answer of 325. Alright, just doing base times height to get these answers right here. Number 9, we got to cut this up even more. So just get the cutting. We got ourselves a 3 by 8. How did I get 8 here? I did 6 plus 2. 6 plus 2 is 8, so 3 by 8 is 24. So 24 for that one. How about we cut? I'm going to go here. This is a 2 by... this whole length would be 12. So this whole length here is going to be 12 minus 3 minus 2. So 12 minus 5 is 7. So this is a 2 by 7, which is 14. Alright. Next, I can cut here. This is a 6 by 7, which is 42. And the last thing I got to do is figure out what's the length of this piece here. And then I can do 2 by blah. Well, if this whole length is 8, and this is the length of 2, this is 6. I'm having a brain fart. Hi. You gotta go away. You gotta go away. Okay. Sorry, that was my son. Alright, let's see here. How can we figure out? I'm pretty sure it's 2. But how do you figure that out? Huh. Interesting. Let's move on to the next one. We'll think about that last one. Right here we've got 2 trapezoids. You've got a base of 4 and a base of 25. Hey, you guys need to go away. Alright, so it's 2 trapezoids. We do the average of the bases times the height. That's this first one. We do the average of the bases times the height for the second one. And this is 332 for this, plus 200 for this. Hi, Shepherd. You want to say hi? You want to put your hand in there? Go ahead. Hi. Eden, you want to say hi? Okay, put your hand in there. Say hi. Okay, now go. You guys gotta go. Alright, the next big question here is, what is the area of this little square? It's gotta be a 2 by 2, right? Huh. This is what I get for not doing this beforehand. Okay, let's see.
No, don't go in here.
That's 2. It's just gotta be a 2 by 2. So it's gotta be 4. But that's visual. I don't like that. So 42 plus 14 plus 4 plus 24. Pretty sure the answer is 84 if I was a guessing man. This is 6. What's the indication for that one? Yeah, maybe we just need to cut it up differently. Probably need to cut it up differently. Alright, so I'm leaving that one to you guys to try to figure out. Pretty sure it's 84. If it's something different, let me know. Alright, have a good day, guys.